your notes as 3.3 first derivative test. The first derivative test is used to help you guys find relative minimums and relative maximums. We've talked about extrema, which means the absolute maximum and the absolute minimum, but those values were the absolute minimum or absolute maximum within a certain given interval. So now what you're going to do is find what we call relative maximum, relative minimum, which is something that you did back in Algebra 2. So for example, let's say that you have a graph that does this. You don't necessarily have to write this part down. I guess I'll tell you guys when you start writing. But when you did this back in Algebra 2, your job was to look at an entire graph. So when we're finding relative minimums and maximums, you are looking at a whole graph, not just an interval. And what you had to do on the calculator a couple years ago was you just had to recognize that that point right there was a minimum value. And you remember how you would go second trace number 3, I think, and you'd have to go to the left side and press enter, and you go to the right side, you press enter again, and it would guess the lowest point for you. Well, that was a couple of years ago, back when math was a little bit easier. Now your job is going to be to use calculus to find that relative minimum. What would this point be called? The same thing. It's another lowest point. So notice on the left side of this point, the graph is headed down, and then when you get past the relative minimum, what's happening to the graph? Going back up. So in other words, your slope on the left side is negative, and the slope on the right side is positive. All right, so relative minimum. All right, this is a trick question. What's this point up here called?
Relative max.
Yes, it's a relative maximum. But notice on the left side of it, the slope is positive, and then on the right side of it, the slope is negative. That's what you're going to need to do, is figure out what's happening on the left side of a high point and what's happening on the right side of it, and that will help you determine whether or not it is a maximum or a minimum without actually having to look at the graph. So this right here is a relative maximum. All right, so definitions. Can I flip? I told you guys you didn't have to write this down anyway. Relative maximum, let's write down a fancy definition for this. A relative max happens when the derivative of a function, derivative of f of x, what does the derivative tell you? Is the slope. So when the slope goes from increasing to decreasing. In other words, kind of like there's a hill there. We've got a hill. And then the relative minimum means that the derivative, which of course means the slope, goes from decreasing to increasing. What do you think we could call it? Not a hill. A valley, yeah. We can call it a valley. So to calculate these relative minimums and relative maximums, the two-step process. And the steps are not horrible, maybe detailed, but they're not horrible. Can I flip pages? No. Yes? No. 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 Okay. The two-step process, and actually, you know what, I can probably fit these steps right on this page here too, or right on this page too. Two steps, the first step being that you need to find the critical numbers. So So we're gonna find the relative minimum, the relative maximum by finding critical numbers, which shouldn't be new information to you. Find critical numbers, and then the second thing that you're going to do is check regions on either side, and I will explain to you what that means with an example. Alright, so I'm going to say this. If you end up with one critical number, you need to check what's happening on the left side of that critical number, and you need to figure out what's happening on the right side of that critical number. So once you check the left and the right, if the slope is getting bigger on the left side and then getting smaller on the right side, you know that that critical number is actually a what? A maximum. And then if the opposite happens, you're going to know that it is a minimum. So let's say that you have two critical numbers. How many regions are you going to check?
4.
2, 4.
You always check one more than the number of region or the number of critical numbers that you have. So if you have two, you have a critical number here, you have a critical number here, you need to check what's happening on this side, what's happening on this side, and then what's happening over here on this side. So 1, 2, 3. So if you have 3 critical numbers, you're going to be checking 4 regions. If you have 5 critical numbers, you're going to be checking 6 regions. So that's when it gets ugly, when you have to check that many regions. Joey, were you going to say something? No. All right. Are we good now?
Yeah.
All right, so example. F of x is equal to x squared minus 4 to the 2/3 power. Your job is to figure out whether or not there are any critical numbers. So in order to figure out critical numbers, you are going to need to find the derivative. So we need to find the derivative of this. What is your gut telling you that you need to do to find the derivative of this? The chain rule. So go to the right, name your u. What's your u?
X squared minus 4.
X squared minus 4. What's the derivative?
2x.
2x. Alright, so I'm going to rewrite f of x. I am going to rewrite it as u to the 2/3 power. So when you find the derivative is 2/3 u, subtract 1 from the power, you get negative 1/3, and you multiply it by the derivative of u. So we're going to end up with 2/3. What's u?
X squared minus 4.
X squared minus 4 to the negative 1/3 power times the derivative of u, which is 2x, which is equal to, clean this up a little bit, what's 2/3 times 2x? 4x over 3 times x squared minus 4 to the negative 1/3. I've said it before, I will say it again. Make sure that you do not distribute this 4x over 3 into the parentheses. Why can you not do that? Because the power. I think I heard someone say it. This power right here makes us not be able to do that. If that power was not there, it would be assumed to be a 1 power, and then you could distribute it. All right, this right here is a negative power, so what do I do to it? Move it to the bottom. All right, so I'm going to rewrite, I think I'm going to read it over here because I'm running out of room. So I have 4x over, I'm going to put this x squared minus 4 to the positive 1/3 power next to the 3 on the bottom. So I have 3 times x squared minus 4 to the positive 1/3 power. we have critical numbers anywhere that we could have issues with this derivative. Where could we have some issues? At 2. Very nice. If I put a 2 in here and squared it, I would get 4. Minus 4 would get me 0. And then when you take 0 to the 1/3 power, what does that mean, by the way? What is 0 to the 1/3 power? It is the cubed root of 0. You take the cube root of 0, you get 0. We have 0 on the bottom. So that means that we have critical numbers at, it's actually 2 places. Positive and -2. Very nice. So I'm going to put a big old box around these, and I am going to name these as CNs. What does that mean?
Critical numbers.
Critical numbers. Yes.
Why couldn't you just figure that out from the initial equation?
Well, sometimes when you find the derivative, it will give you something different on the bottom. Now, if you want me to give you an example of that, I probably won't be able to come up with one. But sometimes the derivative gives you something different than on the original problem. Okay? All right. It's so funny.
It doesn't sneak in here today, I just noticed that. Or
I
does
am not going to comment on that because, All right. Now. I will later though.
Oh yeah.
This, we also, if you remember right, when you're finding critical numbers, you have to put this equal to 0. So I'm going to do that right now. Over here on the side, I've got 4x over 3 times x squared minus 4 to the 1/3 power. I put it equal to 0. Same situation that's been coming up almost daily. Ignore the bottom. In other words, you're multiplying both the left and the right by the denominator. The denominator's wiping out, so you ignore it. So 4x is equal to 0. So what's x?
0.
X is equal to 0. All right, what do we call this? A critical, we call it 0. Very good. Wow. We call it a critical number. All right, how many critical numbers do we have?
3.
We have 3 critical numbers. So what we need to do is check 4 regions. Very good. Now I'm going to have to flip pages here because I am running out of room. So when I flip pages, I'm just going to need you guys to, actually, I'm good. I think I can remember all of these. We have 3 critical numbers. What is the smallest critical number up there? -2. What is the biggest critical number?
2.
+2, and then the one in the middle is
0.
0. So what we're going to do is check what's happening on the left side of -2, what's happening in between 2 and 0, what's happening in between 0 and 2, and then what is happening after 2. Okay? 4 places.
Could you have done after? Before -2?
You can do it in any order that you want to. Is that what you're asking me about the order?
No.
What are you asking me?
I'm saying that instead of going after 2, could you have done it before -2?
We are going to check before -2.
Oh,
Yep, we're going to check before -2.
Oh,
In
just
between.
kidding.
That's good. All right. Okay. Are we good?
Yeah.
All right. So what I'm going to do now for step 2 is I am going to label all of my regions. I'm going to label all my regions. This is all one problem, yes. You have 7 problems to do today, by the way.
Oh.
The two. Okay. All right, so the regions. Remember, I'm gonna jot these numbers down, but I have CNs at -2, 0, and 2. So what I need to do is check what's happening on the left of -2. So my first region, I am going to label like this. Region number 1, I am going to check to see what's happening from -infinity all the way up to -2. Now I'll explain to you what to do here in just a minute. But region 2, I'm gonna check what's happening from -2 up to 0. Region 3, I'm gonna check what's happening from 0 up to my next critical number, which is 2. And then my 4th region, what I'm gonna do is check what's happening from 2 to +infinity. Now, the cool thing about this is that you only have to ever check one value. Because regardless of how many values you check, the same thing is gonna keep happening over and over and over again. So what you need to do is pick any number you want to that falls in between negative infinity and -2.
-3.
-3. Right? Do I need to draw a number line?
No.
No, are we good? Okay. So pick a number. Keep it simple. Don't pick crazy decimals. Don't pick square roots. Pick nice, pretty numbers. Okay. So for this region, I'm gonna try a -3. X equals -3. What about in this region right here? What about between -2 and 0? What should I check there? -1. That's a good one. Yeah. No, I'm being serious. Gosh. What about from 0 to 2?
1.
We'll try 1. So we're going to check 1. And then what about from 2 to infinity?
3.
All right, so this is what you need to do. You need to take this -3 and you need to plug it into your derivative formula. So find your derivative formula, and I'm going to switch back to that page. Our derivative ended up being this thing right here. So you know what? Type it into your calculator. Go to Y1, type in, what are you going to put around the 4x? Parentheses around your 4x, divided by, in parentheses on the bottom, you have x3 times x squared minus 4. Finish your parentheses. But then you need to put it to a power of 1/3. So when you put it to your power, make sure the 1/3 is in its own set of parentheses. And make yourself a table. You very well could. I don't have the actual values written down here, so. What kind of a number do you get? What kind of a number do you get at -3?
Oh.
Did you make a table? Did you go to -3? Is it, okay, all I really care about is it positive or is it negative? Who cares, if you want to write the decimal down, the value you get, write it down, but I don't care about, it doesn't matter what it is, regardless, or other than the fact that it's positive or it's negative. What do you get, a negative?
Yeah.
All right, so here, what's going to happen, I'm going to write this down. I got a negative. If we have a negative slope,
That's for -3.
sorry, that's okay, thank you. I got a negative here. So what happens from negative infinity all the way up to -2 is you have a negative slope. So that means it's starting up and it's heading down because it has a negative slope. What does that mean about -2?
It would go up.
It is a minimum. What do you think is going to happen on the other side of -2? It's probably going to be a positive. But what I would like you to do is in your table, go to -1. Do you have a positive number?
Yeah.
You should have a positive number. So right here, I'm going to record this as being positive. Go to 1. What's going to happen at 1?
You get a negative.
You're going to get a negative. And here you're going to get a, you're probably going to get a positive. So what's happening is your graph is starting way up here. It's heading down. It's getting to a minimum. It's heading back up. It's getting to a maximum. It's heading back down to a minimum. And then what's happening after that? It's just heading back up and it goes up forever far to the right.
Why couldn't you just graph it? Couldn't you find your answer by just graphing?
Are we in calculus or are we in graphing class? I know, you have that argument, why couldn't we just graph and I could, yeah, that's what the point is calculus can be done without the calculator. But you certainly can use it as a guide, but I'm going to be expecting to see things like this. Okay, now by the way, when it's negative, that means that the graph is increasing or decreasing? It's decreasing, so I'm just going to put a little note here that's decreasing. If it's positive, that means it is increasing. If it's negative, that means that the graph is decreasing, and then here, it is increasing again. All right, so now, remember the goal of this problem was to identify the relative minimums and relative maximums. So, let's talk about this again. From negative infinity to negative 2, the graph is going down. So what do we call negative 2? Negative 2 is going to be a relative minimum. But there's more to it than that. It is a relative minimum, but I want you guys to tell me what it is. It is negative 2, comma something. But you need to find the y value by going back to your original function. So now what do y equals? Because you're giving me the minimum on the original graph. So you got to go back to y equals. Go back to y equals. Type in the original function, x squared minus 4 to the power of 2/3. Make sure the 2/3 power is in parentheses.
0.
Make a table. You get 0? That's nice. Okay. So we have a relative minimum at negative 2, 0. What about 0? What is that? Well, it's a relative what? It's a relative maximum. And we know that that happens at 0, comma, what is it? 2.5 exactly? Or it goes on and on and on? Okay. So we'll say 2.5. And then this point right here, what do you think that's going to be?
0.
It's a relative minimum again. And what are its coordinates?
0.
2, comma. That's what you have to do today. Now, at the beginning of this, I think I told you guys to get out your orange tables, get out your trig tables. I'm changing my mind. I'm going to wait and give you the second example tomorrow, because I don't think for your assignment today that you need the second example. Okay? Veronica, you had your hand up. Oh, okay. Yes.
I don't get the last part. What you just did.
Okay, so are you okay with why I'm saying that negative 2 is a relative minimum? Okay, so watch what's happening. From negative infinity to negative 2. So anywhere from the furthest point to the left as we are heading into the right to get to negative 2, it has a negative slope, it has a negative derivative, so it's going down. So if it's going down and hitting a critical number, we have no choice for it to head up on the other side. So it's a low point, not a high point. And then after it hits its low point, obviously it's going to go up and it's going to hit a high point, and then after the high point it's going to go back down again. So that means that that next critical number is going to be a maximum point. Does that make sense?
Yeah.
And then we're getting the y values here by taking those 3 critical numbers, plugging them back into our original function. Yes?
What if it's not? Like, what if you see, is there ever going to be one that's going to have all positive or all negative?
There is going to be one, and I don't know if it shows up today or if it's going to show up tomorrow, where you're going to have like 2 negatives in a row and then 2 positives, and then that's the case. That just means that you don't have a maximum or a minimum. You only have one or you have the other. Okay? Yes?
What if it increases and then it is a horizontal line and the slope's 0 at that point? Would it still be a max?
No, it doesn't have. That would be a case where you would not have a relative maximum or a minimum. So that would be a line. If you think about a line, and a line doesn't have a high point or a low point. It goes on forever far left and right. The only time that you're going to have maximums and minimums is when you have curves in your graph. Okay? So chances are I'm never going to give you a line. I'm not going to give you a line and say find the absolute maximum and minimum because there isn't one. Okay?